Hello, welcome to AGCAD's webinar New Technology Announcement Cut Openings for Beams and Extra Technology Openings for Doors and Windows. Then you have Linked Architectural Model. So my name is Jacob. I'm working with AGCAD as BIM Application Engineer, and together with AGCAD we're creating solutions for BIM acceleration. So we are working in Revit environment and we're reducing BIM stress by eliminating unnecessary tasks that do not create value by creating those solutions. So one of the examples are cut opening software, and this webinar is about that. So we're going to speak about two different topics. One of them is brand new topic, openings for structural framing category, and another option is openings for windows and doors. Then we have linked architectural model, and we have current structural walls inside of our project. So we're going to use cut opening software, the BIM software, to create precision openings. Previously, you may know the cut opening as a solution that could lay out openings only for MEP, I mean for ducts, pipes, cable trays and conduits, where we clash with structures, but from now on cut opening is capable of working with structural framing category 2, and it is creating the openings with all needed details for structural beams if needed. Yeah, so I don't want to speak about this literally, so just let's go to Revit environment and let's take a look how it is working. Right here I have really simple project, just to show you all the variations that the cut opening is capable to handle. And at the left side I have different beams. So as you can see, I have a metal beam, concrete beam, a wooden beams, a small wooden beam, again metal and concrete ones. I have a situation where I would like to have joint openings. I mean, the beams are near each other, so I can auto join them. Another situation is with an angle to a structure, to the wall, I mean, and another one is with a slope. So we have a start level of 3 meters and the end level of 2 meters. So I have a slope. And the last one is really interesting one. Then we have a partial interference of the beam and the wall. So I think those examples are really interesting for structural engineers, for concrete engineers, and another ones like in this situation where I have just a basic interior wall, a gypsum board wall. So maybe that is more interesting for architects, that they can cut around the beams, the holes cut around the beams. Yeah, so how the work is starting. So the cut opening is capable to work together with Autodesk Revit, and we're using interference check reports from Revit. So the first thing what we have to do is to run the interference check in between structural framings and walls, and save that report somewhere on your computer or server. So I'm saving that on my desktop, and I'm closing that. The next step what we have to do is to go and configure all our openings, how they should be loaded, how they should be sized, how they should be joined, etc, etc. So I'm going to openings configuration, and right here, as you know, maybe not, the cut opening previously worked with MEP elements. So we have split it into lots of the parts, like to make different configurations for rectangular duct, for round duct, for different pipe categories, cable trays, conduits, and right now the newest thing what we have here is beams, I mean structural framing category. Each of these parts have 3 different configuration possibilities. So the first one, I would say it's more not the cut offset but the opening size. Another one is joining openings, and the third one is interference check. So let's go from the first one and take a look how it looks like, how the configuration is set up. So right now we have two different possibilities to apply the cut offset or apply defined opening size. So we're working on such idea. We're taking the range of element sizes from 0 to 100, from 100 to 200, from 200 to 300, etc., etc. And all of these lines could have different different offsets, different top cut offsets, and different bottom cut offsets. So as you can see, from 0 to 100, I would love to have the additional top cut offset 40 mils, and for another size of beam, I would like to have a bit bigger offset, a top offset. As well, I can go and use the apply defined opening sizes. So the same idea, from 0 to 100, I will always use 100 by 100. From 100 to 200, I will always use the opening 200 by 200. So you can choose which one of the configurations you would like to use. And as well, here in the project, I have really little beam. So sometimes it's not necessary to create a very precise beam model, because it's not cost effective to make a model. It's more easier to drill the hole in a building site, not to model it inside of the software. So we have a minimum width and height parameters right here. So in this case, this 50 mils will be used in the first position, and it will never place the openings for elements that are less in size that 50 millimeters, like width and height. Yeah, so that's the idea of the opening size. Another kind of configuration is working with joining openings and the distances between them. So again, the idea here is the same. From this size to this size, I will auto join the openings if my beams are near to each other by 150 mils. Then I have beams from 100 to 200. I will always use auto join functionality, and if they are near to each other by 100 mils. Again, the same for the third line, and for the fourth line, they are too big and I never want to auto join them. So maybe I will join them manually, or I will leave them separated. And the last thing right here, it's the interference check. Shall I make the opening? Then I have a partial interference like this. And what should be the depth? The depth of the element of my opening, starting from my end of the beam. So again, you have to specify the depth offset of your opening. After everything is set, you can create your configuration file. You can share that with your colleagues in the company just by placing it somewhere on a network, and they can use it. Or I would use my personal configurations right now. I'm saving that, I'm clicking OK, and voila, we can start working right now. So the next step what we have to do is to combine the Revit interference check data with our configurations, just to allow our software to combine them and understand what kind of openings for what cases it should use. So we're using grid interference check data, and we're browsing for the file that was saved on our desktop, and we're choosing the configuration name, and automatically it is saying that we're rejecting some openings because they are too small. Okay, so let's take a look. So as I told you before, we have really small beam, and this beam is just rejected by the configuration. So here we wouldn't have any openings, and okay, I'm okay with that. Or I can just go back to my configurations, and the red bubble is telling me that we're missing something. So I know that the minimum width and height is 50. So let's leave it like this, because I just want to show you the functionality. If you are okay with those rejected elements, you can just go with next button, and you will have a table where you can manage all the needed stuff. So I mean, you can find all your elements, you can find all the cut offsets, you can find the additional top cut offset, additional bottom cut offset. Maybe you want to place some kind of I don't know, maybe some plates under the structural beams or something, so you can leave a space, and on the top of the element as well you can leave some space just to lay it in the position easily. So we have such distribution of elements. And the last thing is the combination. So to save data as the XML view, and I'm just calling it simply XML. And we are going to do the last step. The last step is insert openings. I'm browsing for my XML file and I'm clicking next. And right here what I can do, I can check my elements. So for example, I can find openings that will be placed only on the exterior brick block wall or only on generic block wall. So I can find them, I can easily select them, and as you can see, I'm working only with those elements. So if I would insert right now, it would insert openings only for this wall. If I would go like this, again, I will insert only for that one. So I can use any configuration. So I can go with levels, categories, families, types, wherever you have here. So it can work in another way, not by host, but the structural framing. So I can have openings only for this element, openings for only this kind of element. As you can see, this one is selected and this one is selected. So I can easily filter everything. By the way, we have the dynamic section box that is allowing you to review all of the places where you have clashes. And the last thing where we have to do to choose the opening family. So in this place, you can take your family, so you can take our family and your family, you can nest them, and you can have the opening of a metal plate under the beam or something like this. So you can easily place those families into our software. As well, you can create a brand new family and use it in your way. Yeah, so after you set up everything, you just go and insert openings into the model. So it is automatically distributing, automatically looking for the sizes that you defined, automatically joining the openings, adding some offsets, etc., etc. After you click OK, you can go and review all the openings that we have. So we have openings all around our beams. This one is just a really small one, so we don't have a beam, we don't have an opening right here, but we have the openings all around the rest of the beams. Here we have auto joint elements. Here we have an angled beam. So again, it is taking the extremus of element and creating the perpendicular opening to the wall. Right here we have the same situation, just with a slope. And the last one is a partial interference. Let's take from the top view. So as you can see, the beam is going only to this place, and the opening is offsetted a bit. So the opening have its own marking. You can create your own marking, you can change colors, etc., etc. And it is really flexible because we have the parametrics right here, and you can use the parametrics in the way you need. Yeah, and what's more, what about changes? What about changes in the model? For example, you decided to move this beam somewhere here, okay, like this. So the opening remained the same, but the beam is right here. Another situation, I don't know, so with this one, let's move it left. So you moved all the beams from the current positions, and you have to update your opening. So we have opening revision, and it will tell you that we have cutting element change position and unjoin element. So let's go for the unjoin. We're agreeing with last changes. And another one, And another one is cutting element change position and agree with last changes again. I'm closing that and let's take a look. Yeah, right here. So as you can see, this one got a new opening because it is too far from this one, and this is still joined into one because they are near each other, and this one just get back to the previous position. By the way, you can easily join them back or disjoin the elements anytime you want to do this. Yeah, and after you prepared your openings, it is usual that you use some taggings. So I have prepared my tags. Let's go to annotate and let's try to tag all generic models. The standard element with leaders. Yeah, so what do we have here? It's the opening information. So the O stands for wall opening. If you have another kind of openings, for example, floor openings or whatever you have, you can change those letters. But the idea is such that it can take any information from the opening. Imagine here we have such elements. 203 by 353. So here's the values H and B size. The element offset from level. So it is taking this value. It knows that it is rectangular. So we have a shear parameter file where you can take all the parametrics and you can create your tags. Yeah. So all the parameters are available in tags and schedules as well. So you can prepare your own tags and schedules, like a builder's works or something like this. Yeah, and that's the main idea, how the cut opening can handle structural beam categories. And another my example, what I wanted to show to you today is an openings for doors and windows where we have linked architectural model and we have just a structural wall inside of our building. As you can see, the voids do not cut through the current element. It only cuts the wall that is in linked file. So what we are doing in such situation, by the way, this situation is really common in Scandinavian market, and they are using our software a lot in such situations, and they're using this feature, insert and update structural openings. So this feature is reading information from the linked file. You can take any of these doors and windows and you just hit insert. It shows what kind of families do you have in a project, and I have loaded just a sample M door opening just from door library from your Revit. I'm taking any of these types, and I can create some standard type naming, but I just want to show how it is working right now. So I'm clicking OK for doors. It found 3 doors. Once again, I'm clicking for windows. Again, the square opening, just simple square opening. I'm clicking OK. It created 5 openings. And let's go to the project and let's take a look. So as you can see, right now it made the openings. The openings got the information. So my door tag is such. It's 900 by 2 meters and 100 mils, and the doors are the same, I guess. Yeah. So yeah. So from here you can see the height. So it took the element information. It drag that information to the opening. And what about changes? So if I would save this one, I will close it. I will open architectural wall. What about changes? What about if I would like to just move my doors? Let's move them right. So the opening from the architectural wall is moving together, but what about the opening from the structural file? We're gonna see. Yeah, so the doors are moved, but the opening remains in the same position. So again, the same idea as before. We're going to update structural openings. The tool is telling us that we have changed positions, and we're just agreeing with last changes in the project. And that is all. That is how we do. So we have the openings just straight in our model. Yes. So I think I showed everything what I wanted to show today for structural engineers. So we had two different options, openings for line-based elements. So today I showed only beams, but don't forget that this software is working with MEP line-based elements as well. And I just showed you the idea of openings for doors and windows when we have linked architectural model. Yeah, so that's all from my side. And I just want to mention that you can take a free trials of these of our software. You can use one shortcut to all 14 days trials, tools, updates, and more. And you can reach the really wide range of applications, starting from MEP, going to structures, going to BIM management. So you can take a look at our software, and just visit www.aj-cat.com and download from here a shortcut to all tools. And I would like to say thank you for your participation in this webinar. I hope you to see again. So thank you. And now questions and answers. And if you'll have any questions in the future, just don't hesitate to contact us via support@aj-cat.com.